Thank you, Jeff. Yeah, so I originally was going to do a demo today, but I had to fly to the East Coast and had to get up at 3 a.m. to catch a flight. And so I'm a little bit tired, so we're going to have a different format today. So I am going to convince you, even without doing a demo, that you have to look at these command line tools. And the creators of it are so outstanding. And I'm going to be so compelling that you're going to look it up on your own. So hang on, I'm going to share my slides. Hang on 1 second. There you guys, can you see my slides now?
Yes.
Yep.
Perfect. So the reason I wanted to talk to you about Typer and Rich. So there are a few command line tools you should look at. So Typer, so command line tools. So a lot of people are using PyCharm, VS Code, very popular. You can use any variety of tools to edit your code or run code. You can run scripts right from VS Code, for example. But we still need them, even if you use an IDE, because there's still a command line experience, even in VS Code. Everyone has their own preferences, whether it's dark or light, extensions, customizations, but usually you need to share them. Your scripts at some point, if you share them or need to reuse them, usability is a big concern. I mean, I probably not anybody on this call, but occasionally, maybe you've written a script that you wrote one time 6 months ago, and you commented some stuff out and you knew how to run it 6 months ago, but you go back to it and you're not quite sure what the arguments you're supposed to pass are, even for yourself. So, why should you change if you're using different command line tools than the ones that I'm going to talk to you about? You don't have to, but your future self will like the organization and readability of these. So the creators, that's a Star Trek I reference for anybody who remembers Star Trek I. So Typer is created by Sebastian Ramirez, who is the creator of Fast API and tons of open source tools. And one of the reasons that I wanted to talk about Typer and Rich, both of these people, and Rich is an open source package by Will McGugan, who just started textualize.io. They both are phenomenal creators of open source Python tools. I would highly recommend that you follow their GitHub at work, and which I've shared here. Oh, so that's Will McGugan's personal GitHub repository, but he also started a company. In fact, he just said, "Oh, I'm thinking about starting a company," and investors were like, "Take my money," versus the usual kind of startup pitch you have to do. So what are they used for? Typer is the fast API of command line scripting. It's built on Click. But one of the things, if you've heard about Fast API at all, and I hope that you have, it's outstanding. It's built on lots of other tools. And one of the great things about Fast API and these other tools, they're very open about what they use to build it on and the best parts that they took and added on to, and very gracious about sharing the limelight with previous creators. And Rich is a Python library for rich text and beautiful formatting in the terminal. And when I say it is, you can pipex install Rich. So that might be another lightning talk we could give about pipex. I don't think we've talked about that. Have we, Jeff, Glenn?
I've mentioned it a couple of times, but not directly on pipex. I have talked about how pipex is different than pipenv, pip, and poetry and pip tools, but we've never actually specifically talked about pipex.
Yeah, it's a nice way to have a certain kind of package be installed as a global executable on your system. So you can pipx install the rich CLI or Typer CLI or rich. So you can pass all kinds of things to rich, and it color codes and syntax highlights it. You can create all different kinds of experiences, and you can get enrich that Carbon Now experience where you have that little snippet that you've probably seen on Twitter feeds that looks like it was a command line console. You can generate HTML or SVG, and there's a million things that, and what is great about both of these packages, they're used for different things on the command line, is that the documentation is great. And that by itself can carry a lot. So another reason to use them, of course, is that they're highly rated by lots of people. Rich, for example, has 38,000 stars. Typer has 8,000 stars. Fast API, which is a framework built on async and built on all these other things, has 46,000. And I put the comparisons. Flask has 59,000. So in just 2 years, and Flask came out in 2010. So it shows you the traction that their work has gotten, and one of the reasons why you should take a look at it as well. Not to be trendy and not to be cool, but just because they're so powerful. And it would have been better if I could do the demo and show you all the things, but just take it from me that you should look at Typer and Rich, and it will make both of these will make your life better, especially Typer for command line scripts that you're going to run, and it builds in the documentation for it, and it has types. So all of that. Does anybody have any questions?
I have a question.
Oh, sorry. Somebody said V'ger, which is Star Trek 1. Do they have a built-in shell? Sorry. Who was talking? I can stop share.
Well,
Sorry,
I guess,
somebody was saying something.
well, it was me, Jeff, but then at the same time, a question came in from Andrew. So maybe answer his first. Do they have a built-in shell?
So they don't have a built-in shell. These are Python packages that you would import into a script or a terminal, and or a REPL, and you would use them there. And so you would import rich, and then you can import the rich console or formatting messages. So it's much better if you can have clear, understandable output. That's one of the reasons Typer is nice, because it's built on Click, which has a nice feature set and output for command line tools, being able to run just one function. And Rich is a way to make your command line experience beautiful. I mean, if you've seen like basic logs versus structured logs, if you have seen JSON all in one line versus formatted pretty print JSON, but it's like 100x that. You can pass a CSV file to Rich and get it formatted. JSON on one line. Yeah, it's awesome. Anyone else have any questions? Otherwise, I will turn it over to our next speaker. And I apologize that I didn't show you, but you can go take a look at them, and the documentation is great on those.
Karen, I have a question. This is Jeff.
Yes.
So I was just curious for Typer, what does it add on top of Click? I've used Click before. I'm just curious, what additional goodies do I get?
There's a huge number of features that are part of the package, and they have documentation about using Click with Typer, and it talks about the ways that which parts that they have rewritten.
Mhm.
So I think, so Click, you can't install it as an executable. Is that correct?
Yeah, it's just a
Yeah.
library.
So you can run Typer, and then you can have it do autocomplete, auto completions. And
Okay, I don't think,
yeah.
Click doesn't do
And
that. That's cool.
and so you can, let's say you have a script, you have let's say a hello function that's in, and a goodbye function, and then one is supposed to pass a name, and then if you don't pass in the right thing, it just writes the right help message of what you missed without you adding extra handling, like you didn't add a name and now my script is going to crash. It adds a variety of things just out of the box, so it makes it simpler, faster, easy to read. You can add color through that. That one uses, you can use Colorama, and I've seen some other mentions of using Rich with it as well. So it's really, when they say it's the fast API of command line, it really, it's because there's so much baked in of
Mhm.
functionality that then you don't have to write it yourself and handle all these things.
Mhm.
So I know, and it's built on top of Click, so you can use them together, or you can use just Typer the same way Fast API incorporates Starlet and Pydantic and JSON schema usage and a variety of things that so in the end, that's why the adoption has been so fast with some of these tools, and they're being used in production because it's all the goodness and it's open source and everybody is enjoying it. So they're actively committing to the experience and contributing. So
Cool.
usually a 2-year-old package wouldn't necessarily be used in production systems, except for the cutting edge, bleeding edge, startups.
Cool, thanks. Any more
Anybody else?
questions?
I had one question, and I apologize if I missed this in the beginning, but were you going to share the slides or the links in the chat for?
Yes, I can share all. I can do both.
Brilliant, thank you.
There's a question from
can you-
Gary.
Yeah, so Fast API is really a framework, but I'm a fangirl of all the stuff that that is being made, that Sebastian Ramirez is making, and Fast API is the #1. But he has open source Docker modules that have fast Unicorn and Docker, so you can just spin up things. You don't have to figure out how to set it up. Just tons and tons of open source stuff. Will McGugan, they talk about him all the time on PyBites and Talk Python, because they just suggest something to him and he does it 2 days later. So he's like, it's amazing, the stuff that is coming out of there. So Fast API and Django REST. Yeah, so Fast API is it's async, but it is, I think REST is baked in. You can also use GraphQL, but I don't know that much about it. There is a mention of GraphQL handling in their docs, I'm pretty sure, for Fast API. And that's for, we've heard that it's the devil's tool in one of our previous talks. But it's baked in for a modern asynchronous message-driven world, which includes REST-like, handling.
Sharing my screen, do you see it?
Yes, we do, thank you.
We do, and the copy of the link that you wanted has been included in the chat as well.
Thanks for that. So hi, everybody. Thanks for attending. Hope you're staying cool. This is going to be a talk about API Logic Server. It's about creating database-oriented microservices with a low-code extensible approach. Before I get into it, I want to certainly thank a lot of people who have helped. First and foremost is Thomas Paulet. He's in Belgium. So he's fast asleep now, but he's built an awful lot of this stuff. Max Tardivo probably just left because he has a dinner party, but he's helped me through the wizardry of Docker, so I can sort of speak Docker now. Thomas Peters has been working with it to make it run in Kubernetes, and I think he's making good progress on that. And you've already seen my daughter, who's the one who's guilty for introducing me to Python. So this is all her fault. So it's open source, as was mentioned. It's on Git, and that's where also the documentation is. It's in the wiki. So let's go. So this is going to be mostly demo, but I need to do a little context setting first. So in the world of database applications, that's the world I've been involved in for quite some time. Business agility is a major goal, always has been, probably always will be. The missing element of that has always been the back-end business logic. So we're going to talk about that. And in terms of being agile and getting working software quickly, we can't leave behind the extensibility. So a friendly way for programmers to preserve all the things they already know and like. So if we start talking about Agile, we go back to the Agile Manifesto. Many of you may have seen this. It really is pretty much common sense. If you've ever done applications, it's all about getting working software so that customers can see it, or business users can see it and collaborate with it and responding to change. It's about getting working software now. And in particular, for business users, working software means screens. Diagrams and documents are nice, but the screens are, kind of what matters. So the way I think of this is the reality is we have our hapless programmer here and has survived getting their first milestone out and presents it to the business user, and well, it's late and it's not what we meant. Ouch. That's not a happy experience. So we'd like to avoid that. So we introduced low-code tools. I think that's a wonderful field. But what about the back-end logic? Most of the low-code stuff is kind of like for the front end, and then it's kind of your code goes here, and that's a problem because if you look at an interesting database transactional application, the logic that's sitting behind the API is often nearly half the system. So you can't just leave it out and say, take it. There needs to be some treatment to that to sort of realize the promise of this low-code approach. So there's that. And finally, if we're looking at low-code getting us to our finish line, the reality is there's always something. There's always something that's not automated. And that's what the point we made earlier. We can't give up all the stuff that works. It may not be the fastest, but our coding language, our IDE, our tools like Git and so forth, we can't lose those. So that's kind of what we're after. So let's take a look at our take on low code for business agility. And here it is. So I'm going to motivate Karen's talk about command lines with sort of what you would have otherwise. So here's a command line. So the system introduces itself and tells you what its commands are. So what it says here is we can create it by saying create. So what we're going to do here is create a project. We'll talk more about that in a second. But the first thing we need to do is tell it the name of our project. So we're Bay Piggies, so we'll call it BP.
Hey, Val, could I interrupt just for a second to keep the flow going? One of the things that would make it a little bit better for us is to make the font slightly bigger, holding down the Apple button and pressing the plus bit. Yeah, like that. Maybe once or twice more.
Thanks for that.
Sure. Sorry to interrupt. Keep going.
No, please. And I should say, please interrupt, because I'd like to think that by the time we finish this, you think you could do it. But that won't happen if I confuse you and you don't ask questions. So please jump in and, we'll be listening or try to listen. So the first thing we ask you is what's your project name? And the second thing we need to know is where's your database? Now the system comes packaged with a sample database. It's a variation of Northwind. And if I just hit enter, which we want people to do for the out-of-box experience, it would use that. I'm going to use Northwind minus because the standard Northwind comes with customizations that are done, and people get confused about how much was done automatically and how much did you add sort of magic code to that wouldn't be true for me if I just started. So this is using Northwind, kind of a standard database. It's a SQLite database, by the way. What would I get? So I let it rip. It's now built it's chatty. So it's built BP. So a project, it's a project, it's a directory. So I use both PyCharm and Visual Code. So this is a Mac, as you can probably see. If I say code BP, if you install a special wingding, it'll just start up Visual Studio Code. So we've built the project. Here's the project. We'll go into this in detail. We've built it for both Docker, so you can run it under Docker, or you can run it under kind of what I would call a local install, the VE and V stuff. So that's what we're going to do here in this demo, because most people will probably be familiar with it. So we start up a terminal in Visual Code and say, go install yourself. And part of the project built included a requirements.txt, so Visual Code knows what to do with that. It says, aha, I found your virtual environment, shall we use it? Sure. So at this point, we've got a project ready to run. The system is built, the launch configurations, so I don't have to fiddle with that stuff. So this launch configuration starts the project. I can go up here and run it. Let me just refresh it. So you can see this is Northwind. I'm sure you've all seen probably some element of it. So I can go look at customer. So this is a list of customers. It's scrollable. It's paginated, I meant to say. And it's an interesting application because it also lets me go to related data. So for the customer, I can drill down to see the orders. So how did it figure that out? You probably would have guessed that it uses the foreign keys that it finds in the database. So I've got that going for me. That's kind of nice. So it's a multi-page, multi-table application. I can drill further down to look at the order and what I bought or what somebody bought. This is actually pretty clever because the list of the order details doesn't actually include the product. It just includes a product ID. So the system's actually added intelligent automatic joins to say, geez, an ID, that sounds pretty boring, but I see here this field, it's got the word name in it. Let me just join that in for you. You can override that, but you're sort of off and running. So at this point, you've got an application running. We talked about collaborating with business users. They can start to see their data now and say, wait a minute, you got this wrong. Customers have multiple addresses, the sort of thing you typically hear, but you hear it 10 minutes into the project, not 10 months into the project. So you can fix it quickly and not have a heart attack. Okay, any questions before we move on?
Well, as the friendly neighborhood audience plant, I would love to get a clarifying question in about, I noticed you mentioned that this is using Northwind. This works for other databases that aren't just Northwind?
Yeah, it works for pretty much all, thank you. It works for all the pretty much standard SQL databases. It's been tested with MySQL, Postgres, Microsoft SQL Server, the usual suspects. So, and I've run them under Docker, I've run them native. So this is all based on underneath. One of the pieces that it's based on is SQL Alchemy. So that thing where you said your database in the very beginning, that was normally you provide a SQL Alchemy URL, which is hours of fun to try to figure out how many slashes dance on the head of a pin. Okay, so let's pick back up here. So that's creating our project. So what actually happened here? API Logic Server is this thing. We'll talk more about this. It created this project, which you briefly saw. And by running that project, you got the app, which we just looked at. Underneath the app, there's the API. Let's have a look at that real quick. So in addition to the API, you get the Swagger. So that's all built for you. This is very handy if you're coding a front end. You can run it. It tells you, the URIs and stuff that you need to do to get things to work. All right. So now you've got an interesting app. You've got an interesting API. What more could you want? We already did that. One of the things I like about this is everybody's deep in some technology, but not all technologies. So it was nice to get to that point of having stuff running, not to have to paint a jillion screens, not to have to learn HTML or learn, some framework for JavaScript. It just says, look, let's just get going. So there's zero learning curve, yet you can start to engage with your business users. So what is API Logic Server? So we've seen a bit of it. What you saw was the command language interface. That was this thing down here. In addition, the thing that you install, so the install is either a pip install, just like you'd kind of expect, or there's a Docker that you can get. In either case, the result is the same. It's the CLI plus various runtimes that are behind this application, this project. We call this an API Logic project. That's the API itself, the UI rules. We'll take a look at that. I mentioned SQL Alchemy already. This is the stuff that Thomas Pillay fellow wrote. And again, another pictorial of this is the CLI built this project that we have peeking out here. And this project is using these runtimes that are now part of your VENV. Does that make sense?
It does.
Amazing. So we'll take a look at the rules in a second because that's the fun part. Let's understand what it is to customize stuff. So first of all, what is it that we got? So we got a fairly nicely behaved project. This actually down here is this thing that runs. That's what we ran. Inside my database, if you're a SQL Alchemy person, you know that to get SQL Alchemy to go, the gasoline that you got to feed that engine is all these model files. So it built those for me. How to build that? Embedded in API Logic Server, I didn't show it on the diagram, is SQLA CodeGen. So when you point it toward database XYZ, it runs SQLA CodeGen and you get these models. So you're off and running with that. Now let's say you're looking at the API and you're going, geez, I didn't want to expose the table that says people that we want to promote or put in jail or something horrible. So the API is actually, one of the points I want to make here is that you're probably guessing this is code generation. And I guess technically that's true, but I regard the code as more models than code. And what do I mean by that? So here's the entire API. That's all there was to it. And that Saffir's API thing that I mentioned a moment ago is introspecting these models and figuring out it knows it's a database, it's got get, put, and delete, it knows what the attributes are, and so forth and so on. And even if I don't know anything about much about Python, I can decide not to expose something just by commenting it out. So that's how we got the API. The UI is down here. Again, you're expecting to see a bunch of HTML gobbledygook and JavaScript, which we all run and hide from. Not so. What this built is a YAML file, which basically just lists the attributes And if I want to sort of give them different captions or hide some or put them in a different order and so forth, I just edit this YAML file and restart the application. So making little minor tweaks to the API or the application is still kind of almost the zero learning curve. I want to make one point about the UI that we saw, which I guess I've just this UI. I don't expect that to be your finished application. It's really for two things. Number one, as we said, the collaborating virtually instantly with your business users, and secondly, some set of the sort of apps in your system are going to be very boring back-end applications, yet they're expensive to build. So that back office admin app, perhaps you can find use for that here. The sort of more finished, polished apps use the API. The API that we just showed you is exactly what you want to build those applications on. So that's what we got sort of out of the box with minimal customization. Does that, first of all, make sense to everybody? Anything anybody wants to jump in and ask about?
Val, a question.
Sure.
Maybe I missed something, but where did the database schema come from? I mean, what was the first input that defined all the records and foreign keys and whatnot?
Right. Up here, it's right here. We said Northwind minus. That's a signal. Normally, you'd give a database URL. And I mentioned the tool SQLA code gen. If you've used SQL Alchemy, you've probably heard of that. That you can sort of point that at so you open the database and say SQLA code gen, give me a data model for this, and it'll generate all those model files by looking at all the things you just said. So SQL Alchemy introspects and gives an API for the schema, and SQLA code gen builds the model files from that. Can I answer your question?
Yeah. Okay. So in this example, it came from an existing database. So
that's right. It's that Northwind database, just a common sample. Exactly.
Okay. So then, if I wanted to start from scratch, for my application, would I need to first build the database, for example, with SQL Alchemy, or
no? Well, you could build it. I'm sorry, I didn't mean to interrupt, but yes, you build it any way you want. If you like SQL tools, if you like SQL command line, whatever, just, and if you already got one, that there's another path for that. But generally, the path a lot of people are on is they've got a database, they want an API for it. So just tell us where your database is and you're off and running.
Thank you.
Okay, thanks for the question. Okay, so now what I'm going to, so I wanted to be careful here because I wanted to be
Dad, someone else came off mute, I think.
Please, go ahead.
Is that?
I had a little research question, which is I'm trying to determine whether this is similar to, different from, compatible with, in terms of the API, Apache Arrow, which has its own app accelerator. And is that something that you can work with, or is it different, or have you looked at it at all?
I haven't, but I can tell you the fellow that built this API, this Thomas Pollet fellow, it's a little like GraphQL in gross spirit. By that I mean there's one form of API, and I've been involved with these personally, where the API creator, the programmer says, I'm going to sort of build my API and I'm going to guess in advance what everybody wants to do. And that's fine. If you're building in-house applications, that's probably quite good. But when APIs get turned out into the public, that often doesn't turn out to be the right thing. There's this sort of, it gives you too much or not enough. So it gives you too much, you throw away most of the data, or doesn't give you enough, you got to do lots of commands. So these commands that let the client say, that's what GraphQL is, I want this from here and that from there. And this. So JSON API is a very similar approach to that, except it's a REST API. So in the API itself, and you can export using this product, I think that's a good way to do it. You can say, I want customers, and also I want the orders, and I want the the cities joined in or something like that. But it's the client saying that, so that you don't have the problem of guessing in advance the wrong data for your client. So it's called JSON API, and that's a style of API.
Thank you.
Sure. All right. So back to my script here. So this is the sort of out of the box, just give us your database and you get this much. And at this point, we expect you to sort of become super programmer and take it from there. I'm going to fast forward and I'm going to put this guy down and let it relax. So here's the, now colorful, because I've added code to it, customized version of that same project. And what have I customized? For our purposes, two things, and only two things. So the first problem is, getting back to the gentleman's question just now, there's kind of a generic, they call it JSON API, but what if I want an endpoint that looks just the way I want it to look? So in addition to this thing that I showed you earlier, that says, here's all the data models, blah, blah, blah. That's not what I want. Well, I want that, but also I want this. Oh, do I need to do this? Is that better?
And that looks interesting. It's I'm going
So
to have to go ask the Arrow people if this is what they're working with.
I beg your pardon?
It's just, they have a whole way of transporting data from front to the back of various subsystems within data engineering. And it would do things like this. So this is what's really interesting.
Yeah, so this is all it takes. So let's just break this down. This says, I'm an API, I'm an endpoint. Because it's part of this class here, I'm going to show up in the Swagger. This is where I'm a nice guy. And I'm going to give you some sample data that we'll see. And my entire API is take the payload and convert it from JSON into basically a dictionary and save it. So that's an entire API. And the reason that's a small API is because something we'll talk about in a moment, namely all the business logic. What rules mean is that if I just save stuff underneath the API, remember that iceberg that you saw, all the rules are lurking, ready to watch the data and compute things like what's the customer's balance and can they afford it? And should I send a message to somebody and should I send an email? All that stuff is encapsulated into the API. So all I really have to do is basically build some objects and save them, which is what this thing will do. So let's put a breakpoint here. So that's step one. We want to customize the API. So let's go back to here. We'll see that in just a moment. So I think we've done that. So I've made the point that we have a new endpoint. We've sort of set a breakpoint for our debugger. We'll run the Swagger in just a second. So you've seen before, the previous speaker mentioned, there are things that can produce APIs. There are things that can produce user interfaces. Our little sort of special, cup, trophy cup here is the logic. And what I mean by logic is multi-table, and that's the key word there, derivations and constraints. So you've seen various, packages that will say, is this field null? Or is this field got more than 5 characters in it? Or is this field one of the values A, B, and C? And that's good stuff. But if you're an application developer, that's a very tiny portion of the kind of logic you're going to write. I mean, it's minuscule. Much more interesting is multi-table derivations and constraints, of which we'll give an example in a moment. Now, there's a metaphor I'm going to use quite a lot, that of a spreadsheet. So let's, this is Google spreadsheets, but it's the same in any spreadsheet. If I say this cell here is the sum of this column, you're done, right? You've told Google Sheets or what all it needs to know that if I change the number here, this balance will go up. If I make it go higher or lower, if I insert a row, if I delete a row, all that sort of dependency management logic, did this change, then I do that, is automated by a spreadsheet. So why can't we have that for application development? That's really the message, and now we do. So I'm going to show you how to, let's back up for a second. We're going to go through how to build this in a second, but let's just sort of cut to the bottom line. Basically, the way you might build a system, there's many ways. You might go through a normal process to gather the requirements from people, the logic requirements. One way of doing that is with a TDD tool, test-driven development tool. So this package is, I forget the name of it suddenly. Behave. Thank you. Read your own screen. It packages the Behave product where I can sit with my business unit and have this kind of domain-specific language to identify my scenarios and use cases and so forth. And one of them might be check credit. So this Northwind database is customers, orders, items, and products. And one of our requirements is to check credit. So I'd ask my user, what does that mean? What does it mean to check credit? And we get our trusty cocktail napkin out. These are just comments. They say, well, that means the balance is going to be less than the credit limit. So we write that down. And now we do a stepwise definition of terms. What's the balance? Well, that's the sum of the orders amount totals, but only for the orders that are not yet shipped. Okay. What's the amount total? Well, that's the sum of the order detail amounts, which is the price times the quantity, where the price comes from the product. So this is logic that you might give to a programmer that explains what they've got to go code. And as a developer, I've done this, and it's on our website or our documentation. If I took this spec, I look at it and go, it's for place order, but that's like our spreadsheet. It's also telling me what it means to delete an order. The balance goes down, or to move an order from customer 1 to customer 2, or to add another line item to it. There's about a dozen use cases governed by this logic. And if I went and coded all that in trusty Python, that's going to be 200 lines of code. So, I mean, that's the way we've been doing it, right? And the expectation is, well, of course, it's domain-specific logic. It's got to be domain-specific code. What else could you do? Well, you could use rules. So what we've introduced in this sort of little trophy that I was getting at is, this is the declare logic part of our project, where basically these get translated into Python. So these become now executable. In fact, these 5 rules, which match virtually identically to our spec, are executable. And in fact, they govern the 12 use cases that we just talked about, replacing the 200 lines of code that I would have written. So what's it like to enter rules? So let's go over to our development area here. So here are the rules. This is the file we were just looking at. So let's pretend they're not there. So normally this file would be cut off about here. And basically, it's not your code goes here, it's your rules go here. And this is all just comments, me trying to explain to people what's going on. Let's build a rule. So the first thing I like is, as a developer, is like, oh, there's my rules. So there's a constraint. I know it. I probably can guess what a constraint is. Parenthesis. Now I use code completion. And I can say I'm validating models. Oh, yes, I'm with you. Customer, and so forth, right? So I'm building up these rules in Python. In my PyCharm works the same way. This is VS Code, as you probably know. And I'm building up my rules with code completion based on all the other stuff like my models and so forth in my application that got built for me. And it winds up looking like this. Okay. So here's the customer balance rule. Let me just, this is a very big deal. So what this rule is saying is that the customer's balance is adjusted. I'll come back to adjusted. And this if and only if. So the first thing that's saying is if I make an update, and let's say I change the order's date. No, that's a bad example. If I change the order's shipping address, there's no impact. So this rule kind of prunes itself. But if I change the order's amount total or its ship date, then the rule says, wait a minute, you've changed something in me that's referred to by another rule, like a spreadsheet. I got to go do something about that. You might reasonably guess that this looks kind of like, refried SQL, where you can see the SQL select sum of blah, blah, blah. It's not. It's totally not that, because that would go remarkably slowly. Because what you don't want to do, imagine a customer had 1,000 orders, is add up 1,000 orders, and then for the new order of $20, get the total of the 1,000 orders and add 20 to it. That's going to be very, very slow. So what this is doing is an adjustment. That is, if you add an order for $20, it'll adjust the customer's balance up 20. And it'll adjust it down 20 if I delete the order. And it'll adjust it up and down if I change the ship date. And there's use cases that you might not immediately notice, but the rules will. What if I move an order from customer 1 to customer 2? This rule will realize that and make customer 1 balance go down, customer 2 balance go up. So all that dependency management and SQL and the optimizations and the pruning, all that stuff is handled by the rule engine. Let me stop there. Is that making sense? Silence. Are we in oblivion now?
I think it makes sense. I don't see anyone asking any more questions. I
Oh
think
my
we're great.
God. Okay, so we've done this. We're going to come back to the debugging of it in a second. But I want to make the debugger will make much more sense if I introduce one more concept. So we started this off by saying low code is wonderful. Rules are kind of low code logic, if you want to think of it that way. But low code for UI is great, but I need to extend it and customize it and so forth. And the same thing goes for logic. Rules are all about your domain model. They're about, the tables and columns in your database. And rules are very good, much better than you'd think at automating the logic associated with that, like well in excess of 90%, 95% even, of your sort of SQL logic is automated by rules, but not 100%. And certainly not things that aren't about the database domain, like sending messages or sending email or blah, blah, blah. So in the same way that sort of the low code needs to be extensible, logic needs to be extensible. So logic is really defined as rules plus code. And the way we do that is just another kind of rule called an event. And we try to be honest with our term. An event is just, run my code. So I identify the code I want you to run. That's this method up here. And the rule engine will just call out to your event when appropriate, when the order is getting changed. And it'll pass it what it needs. It'll pass it the row that's being altered. Nicely, it'll pass it the old row, the row that happened before the update happened. So I can do state transition logic. Everybody's favorite example is, in every company, of course, there's a rule that says raises for programmers must be over 20%, right? So to be able to enforce that rule, you need to know what the new raise is and what the new salary is and what the old salary is, so you can make sure that the raise is sufficient. In this particular example, we're not giving raises. We're going to sort of just log something. We're kind of mimicking sending an email, but we can set a breakpoint. So now we've got 2 breakpoints set. Let's take a dive off the high board and run our application. So what we've teed up here is we've defined a custom API. We got a system, we got a project. The project ran, it built our default API, default UI. Then we used VS Code to add a new endpoint for add order. And we added some rules and this event that we're looking at here. So let's go back to the factory here. This is the exciting part of the demo. This is where I have my daily heart attack. So this is the way you get to this, to the Swagger. And oh goody, this additional endpoint that we built with that code that we saw for the API shows up with its endpoints, and add order was the one we added, if you remember. So I can open that up. Here, remember we said it produces kind of a sample data for trying it out, so we try it out. So now we're ready to run. And we hit our breakpoint. So this is the code we added for the endpoint. And we hit our breakpoint, and just like you're used to, you can see the order that we've dragged in from the API. So again, and this is the entire code there was. So we say, okay, well, that's looking good. Let's keep going till you hear glass, as they say. So now the rule engine is running. And it's doing its little rule thing. It's producing a very nice indented list that shows the chaining of the rules and the complete state of the row objects, which is amazingly helpful. So you can see which rules are firing, what they're doing to the row, but our transaction is still in process. And the rule engine has now called out to our event, and here we are. So I can look at my row. This is my order row. And I can look at the variables in my row and go, yeah, it's doing what it should do. Here's my sales rep, blah, blah, blah. So all the things you're used to in Python and in VS Code for, code completion, debugging. We haven't talked about Git, but all that applies as well. All the tools you're used to are completely enabled, right? In the form you'd expect. And we'll just continue on here. And we're back, and it worked. Who knew? So that's API Logic Server. So let me give you a little bit about what was going on there. So people are wondering, how do the rules work? How do the rules fire? When we generated the application, one of the things we put into it was activating the rules by calling out to execute this code. Remember, this is where the rules were. That just defined rules. Nothing, no disk accesses occurred. We just sort of remembered the rules in memory. And then the API or your code goes and does its normal updates and deletes through SQL Alchemy, boing, boing, boing. Nothing is different there at all. And now when you find the commit, what the logic engine has done is hooked into the SQL Alchemy before flush. And what we get is a list of the rows that you inserted, updated, or deleted. And we basically take each of those roles and submit them to the rule engine with its old copy and its new copy. The rule engine looks at what changed, reacts to the changes, and chains, like a spreadsheet does, right? This is where your event got invoked and the rules got invoked. One of the points I want to make is maybe you've already got an application, but this rule stuff is quite powerful. I mean, that 40 to 1 is nothing to sneeze at. This is just a SQL Alchemy. This is a SQL Alchemy story. So if you're using SQL Alchemy, you can use this package called Logic Bank, which is used by API Logic Server as the rule engine for your application that's not API Logic Server. Does that make sense? That it's unbundled.
What was the last sentence you said after, does it make sense?
I said it's the logic service is unbundled
Oh,
from API
unbundled,
Logic Server.
unbundled. All right, thank you.
So my recommendation would be to use them together, but if you've already got an application, obviously that ship has sailed. The documentation looks a little like this. For example, this shows the rule types with these examples turn out to be very, very helpful. So there you have it. That's API Logic Server. It builds low-code microservices for databases. It's extensible in all the ways you know and perhaps even love. But mainly, what it brings to the party is this low-code logic using rules extensible with Python to save you fecundous amounts of work on your project. Questions?
Could we actually have the examples of rules, the previous slide up for the questions? Because I think people might want to chew on that a little bit. It was pretty juicy.
It's actually quite dense. It is juicy to the point of being dense. Maybe like a very ripe apricot.
Don't see questions. I do see quite a few exclamations. Wow, better than chocolate. Good stuff. So people are really liking it.
I have a couple
I'm
questions.
a fan of chocolate, that's for sure.
Josh, go ahead.
So this is Jeff. I was just gonna say, I guess, well, now my question is, are those rules only for validating changes, or can they actually update the rows
Oh, no,
before they
that's-
get to the database?
Yeah, it only be quite honestly, if they were only about validating, I wouldn't be wasting your time. It only becomes interesting. Remember, I defined logic as multi-table derivations computing and constraints. So all these formulas, think about what Katrina, thank you for pointing this out. If you look at sum and count, this, if I use the term parent and child, it's just simple for one-to-many relationship, like the customer is the parent, the order is the child, right? These are computations in parents that look at changes to the children. Copy is a change to the child that looks at the parent. And formula are changes within that row. So what this is showing is over the graph of your database, you're able to compute across relationships with something very much more like a spreadsheet than low-level code. And it's our job to not only do these things, but very, very significantly to optimize them. And the optimizations here are literally multiple orders of magnitude in terms of what it would be if they weren't optimized. And I can't overstate that. There is, for example, people often ask, well, this is kind of like a rule engine, isn't it? It is kind of like a rule engine. In fact, these rules are production rules by any definition. The difference, and it's an enormous difference, is that these rules are hooked into your persistence and can look at the old and the new values and can compute deltas and use that for optimization, for example, pruning themselves. Whereas a rule engine would say, if you have the sum of the customer's balance, well, we have to go add them all up. The sum of the order totals, we got to add up all the order totals. Wait a minute, that's not good enough because the orders themselves, the order amount totals were the sum of the line item, the order detail amounts. So you got a cascade multi-level SQL select sum of, this is the SQL that ate New York, optimized away. That's no longer happening. And literally, this is the definition of transactions that run in minutes versus seconds. So it's an enormous requirement.
Is there any kind of generator or pre-built scenario for the rules?
Can I generate? No, I don't know how to generate rules. I've asked that before. I mean, I can certainly, obviously this is all about generation. We generate your SQL Alchemy models, your API, your UI. That's a lot of and your project, right? But So I have no qualms about generating stuff, as you can tell. I don't know any way to generate rules. I mean, you could maybe introspect the database and look at the data and infer things, but I think that's kind of I've never been able to convince myself that's worth the time. And my objective is just, let's just make the rules simple, right? I mean, that's, if the rules look like the spec, I often describe rules as an executable spec. That's a lot. But if I could, I would. That's
If
my-
we already have an existing application, how do we migrate to include this?
Well, if you've got a database, you can generate the project instantly. And then what it's a matter of is replacing your code by rules. And when I used to work for Sybase, and I went and looked in Sybase's order entry system. Oops, I just muted myself. I went and looked at Sybase's order entry system to answer why is Siri? Can you guys still hear me?
Fine.
I
You're
hit
fine.
a button I shouldn't have hit. Can you still hear me?
Yeah, we still hear you. It's good.
No. What just happened?
Did you mute yourself
Hello?
maybe?
I was hearing you.
There?
I hear you.
Are we back?
Yeah, you're not gone. We still hear you.
Why is this happening?
Kat, can you get a message through that we can hear and probably it's muted on the
Yeah, I'll go tell him.
Hello?
Yeah, we hear you.
Hey, Dad, I think you just turned off the sound on your computer.
Well, I didn't, but it's fighting with,
Well, we can hear you
Testing,
fine.
testing.
you hear me fine?
testing.
Yeah.
Okay,
Yeah, if I can hear you, yeah.
I'm sorry.
That's all right, Val. We hear you the whole time. It's good.
Okay, I'm told that you can hear me, but I can't hear you. It reminds me of a vacation I took where some rich guy in New Hampshire got a phone when phones were first invented. It was outgoing only, which was, I wish we've all had. Remind me, what was the question? Before I so
If you had an
rude.
existing application, how do we migrate to include this?
Trina, what was the question?
You began to talk about Sybase. I'm not sure if that matters.
The question was in the. Whoops, sorry.
Come on, just tell me.
The question was in the chat. It was if we have a pre-built.
Oh, okay, so we have a pre-built application. So what I was explaining is I went into Sybase and looked at their triggers, which were about that thick. And it took maybe 2 hours, so I could just look through the entire application and deduce the rules from it. It was kind of child's play. It looked like a much bigger job than it actually turned out to be. I'm not suggesting you should do that if the system is working, but if you're only a third of the way through, it might be worth a thought, right? So why am I not hearing anything? This is. Okay, are there more questions? If there's more questions, Katrina will forward them to me. Are we done? Okay, I'm seeing thumbs. So I would encourage you to download the product. It's free and fun. Thank you.
Great, thank you.
Hey, thank you, Val. Yes?